Hi and Assalamualaikum. We are from CDCS 115A. Today, our group project will be presenting about waiting line and queuing theory, and we will be using Ayam Gepok Abang Mus at Pusat Pelajar Year 8 Tapah as our main observation. Before we start, let me introduce to our group members, which is first, myself, Nur Safiya binti RAZALIRAKUMA, Adam AIMAN bin AZMAN, and HAMIDAH binti AHMAD. First, for our introduction, we are choosing Ayam Gepok Abang Mus located at UATM Tapah branch at Pusat Pelajar. Its operating time was from Monday to Friday, 10 a.m. to 10 p.m. and only closed at Sunday. Its number of serve was single serve and its business type is cafe. We choose an observation time of 11:30 a.m. to 12:30 p.m. In this next part, we got a few pictures to show, showing our dedication and also a waiting queue at Ayam Gepok Abang Mus Cafe at our observation spots.
Now, let's dive into the core characteristic of the queuing system we observe at Ayam Gepok Abang Mus. We have broke this down into three main categorical arrival, which is arrival, waiting line, and service facility. First, let's look on how customer enter the system. In arrival characteristic, we have calling population. The size of our calling population is limited. It is specifically to the student and the staff on UiTM branch Tapah. On the arrival pattern, customer arrive following the Poisson distribution, meaning that they arrive randomly over time. And lastly, the arrival behavior. We observe two types of behavior. First, most customer are patient and wait for their turn. But we did notice some bulking, where potential customer decide not to join the line after seeing its length. Next, we look at the waiting line characteristic. The line is considered unlimited, meaning that there's no physically preventing more people than join the queue. And the queuing discipline is the system operate as first come first serve or FIFO. It means that this is the standard discipline where the first person to arrive is the first person to be served. And finally, service facility characteristic. First, system configuration. This is a single channel system, meaning that uh, there is one main pass for the customer, and number of phase single phase system. It's mean that each customer only require one stage of service before they finish their transaction and leave. And lastly, the service time pattern on Ayam Gepok Abang Mus. The time taken for each customer follow exponential distribution.
Alright, so next we move to the queuing model. So this slide presents a queuing model parameter used in our analysis. The queuing model applied in this system is MMS. The first M indicate that customer arrival follow a Poisson distribution, while the second M indicate that service time follow an exponential distribution. Next, the arrival rate unit by lambda is 79 customer per hour, indicating a relative high demand for service. The service rate donated by MU 55 customer per hour, which represent a speed of the service process. Lastly, the number of servers in this system is 2, so which help to reduce waiting time. Let's see the performance result of the queuing system. First, the average server utilization is 0.72. This means that the server are busy 72% of the time. It shows that the system is quite busy but still operating in stable condition. Next, the average of number customer in the QL is 1.53. This means that on average about 1 to 2 customers are waiting in the queue at any given time, which indicate that queue length is not too long. The average number of the customer in the system L is 2.97. This includes the customer who are waiting in the queue as well as those who are currently being served. So there are three customers in the system at any time. Moving on to the average waiting time in the queue. WQ customer are waiting 1.16 minutes or 99.72 seconds. So this show that waiting time is relatively short and acceptable. So the average time spent in the system W is 0.04, so this include both of waiting time and service time. So lastly, the probability is the system empty is 0.16. This means that the system is empty only is 16% of the time, so indicate that the system is usually active and serving customer.
Next, for our waiting line characteristic, this waiting line system is classified as a single-phase queuing system based on the MMS model, with two servers S equal to 2, customer arrive randomly, and wait in a single common queue if service is not immediately available. When a server becomes free, the next customer in line is served. Each customer requires only one stage of service before leaving the system.
So after all of the presentation, we came in the conclusion that the our analysis shows that a system with to serve is adequate to handle customer arrival efficiently. This setup prevent the server from being overworked while maintaining the queuing line. And server certification, we found that the both server utilization, which sit at 0.72, and the waiting lamp are relatively short. Generally, the customer should be satisfied with this level of service. And lastly, uh, to this project, we learn how queuing theory can be used to evaluate the restaurant system performance to judge for a better performance. It means that through the project, we have successfully demonstrate how queuing theory and software can be used to evaluate and judge the performance for a real-world restaurant system.
Lastly, in our appendix, we are showing our original QM result using our QM windows.